Hey y'all, welcome back to another video on my LT4 swapped Aston Martin. So today I'm going to talk about one of the pieces of technology that I added, which is, kind of zoom in over here. This is a Motorsport Electronics Apex PDM. So I've been working with the team there to beta test one of the units. So this is a beta unit. So I'll note that I believe the final versions are going to be black and this one is just raw aluminum. But it's pretty cool. If you take a look at it physically, right, it kind of looks like a PDM because that's what it is. I've got it mounted here. I built a little bracket for it. So I'm going to dig into what it can do a little bit. From a basic PDM standpoint, right, it kind of does all the basic PDM things, but I really think the software is kind of the coolest thing about it. From a PDM standpoint, I've had zero issues with it doing power management, and I've tested the limit controls and all those kinds of things. Everything's worked really well, but I'm gonna jump over and show you the software because it has some really nice features. So particularly if you've got a race car or some kind of crazy swap like this, where I've got, a GM engine inside of an Aston Martin Vantage, where it very clearly was not intended to be. The ability for it to integrate with pretty much everything. So I've got some Motec stuff in here. I've got some custom things I'll show you in the interior real quick that I was able to do all the integration, all the controls integrated in the factory systems to work with it. So if I run around the car here, this will make sense as we get into the software. One of the other things that I have in here is this is a Zestec hub that gives me a bunch of pretty advanced functions from a steering wheel standpoint with button controls and light indicators and things. And that's one of the things I've also integrated the PDM with. So I think with that, I'm going to switch over to the software and give you a walkthrough on that. All right, all, welcome back. So in the sake of trying to make this a little bit easier to see, and definitely not because I dropped my laptop and shattered the screen today, we're going to try a screen capture with a voiceover here. So I'm not intending to do a tutorial on how to use the software because I'm pretty sure that the team at Motorsport Electronics will go ahead and do that for you. And again, note that this is a beta version, so I just want to kind of jump through a few of the features in it that I really like and kind of show how it works because in my opinion, the software is what really sets this unit apart. So I have all these different pages here that have the different functions. You see like wipers, headlight washer, blower motor. This is the main page, which gives me some system settings. You can certainly have these control things, but breaking this into pages makes this easier for me. So here's my wipers page. And what I did was set up a wiper inlet or input, I should say. And then I have all of the different digital inputs. These are outputs from the factory controls from basically the control stock that come in. So I have a setting for fast wipers, slow wipers. This is a copy. This does another feature for the park position sensor. I just haven't renamed this yet. And then on the outputs, I have the fast and slow wipers. And so this allows me to use the OEM control stalks on the steering column to control the wipers. And the nice thing is this took, I don't know, 4 minutes to set up and have working. It definitely took me longer to find which wires I need to tap into than it did to set up the software, which kind of isn't always the case. Most of these other ones are pretty straightforward, right? I just have an input and output. Same with blower motor. This is the front heated windshield, glove box latch. So again, these are all pretty simple. But when you get into key inhibit, this is where you start to see where this software is really, really cool. So to make this work, I needed an and. So if both of these are in their on states, so I have a key out input and a handbrake input, and if these are both in an and state, then it turns on this output, which is key inhibit power. In the case of this, it's a way to make sure you can't take the key out without doing certain things. It's just a safety feature that was built into the Aston stock. And since I removed all the factory ECUs and power modules and things, I needed to rebuild that functionality. And this gave me a very, very simple way to do it. Now, I'm going to jump into the CAN setup next because this starts to get a little bit more complicated. And again, I think starts to really show what this can do. So this is all of my CAN stuff, and this is kind of a big mess when you look at it, but it makes sense to me. So what I have is a bunch of different CAN inputs. So if I go to CAN bus and I go to manage CAN inputs, I can see all of these. So these are IDs. I imported these from a .dbc file. I have a Motec M1 ECU, and so I wanted to have a bunch of data that I send to my racing steering wheel. And before, I was doing all of this with an Arduino. So I had an Arduino that listened for these different CAN IDs and then the different messages, right? So if you look in this 0x640, byte 0 and 1, this is the RPM, and I use that to control a shift light on my racing wheel. If we go to 649, this is voltage. 0x64C has two of them, coolant temperature alert and oil pressure alert. 0x64, launch control status, etc. So again, I was able to import the DVC. The Motec DVC is huge and uses up a lot of memory if you record it all. So I only imported the pieces that I wanted. And again, the kind of the little wizard that's built into this allowed me to import it and then just add those as needed. So again, very, very simple to use. I could customize the little endian, extend it, etc. So that's how I brought it in. Now, once it's in, I'll edit one of these, So then you get really cool with these logic blocks. So in this case, I want to set a warning light. So I'm looking for voltage. I'm pulling that in off a CAN. If I look here, 0x649. But I want to set an alert. So if it's 11 or 15, so basically if it's below 11 or above 15, either, right? This is an OR block in this case. If you're into programming, these should all make a lot of sense for you. If you're not, do a little bit of reading. It's pretty easy to research and understand what these do. But these give you a lot of options from a logical standpoint. And then I set an output. And then in this case, what I do is look for these outputs, and then I'm putting them back on the CAN message. So these other ones are a lot simpler. I'm not really doing any tracking these. I'm just bringing them in and setting them to a result. And I do that because these, in my case, I'm essentially using this as a CAN bus translator. So I have a CAN output. So this is the CAN ID and configuration I need. I have a Zestec racing steering wheel, and I need to be able to send it out to it. So in my case, I built a bunch of things based on these variables, put together these 2 bytes here, byte 1, I guess 3 bytes, then byte 6 and 7, which is my RPM. But it let me format it and configure it in exactly the way that I needed to control all the lights on my racing steering wheel. So in my case, I use it as a CAN translator. But if you wanted to have, say you had a button in your car that you wanted to control the glove box latch, well, instead of running this to basically variables, right? I'm pulling the maths, the variables out of these maths functions. I could just have that variable turn on a power output and set the glove box latch, right? And I could open the glove box latch via CAN message, and it's just literally coming in, clicking, and dragging. Like it's really cool. Again, very, very impressed. I'm excited to see kind of where this goes as they continue developing functions on it. But the big thing that I'm happy with right now is I've yet to figure out anything I can't do with the software. That's kind of what I'm normally frustrated with. I get a lot of different hardware. I've tested just about every manufacturer's PDMs in different cars, and you know they do the job. They function, but the software is usually what lets them down. And this one, I mean, I could have a linear motion sensor, you know, decide what temperature I want the interior to be, and then send a CAN bus message out about it. Right? It's really, really neat in that pretty much anything you can come up with to try, this is capable of doing. Again, my functions from a PDM standpoint are pretty standard, right? Wipers, headlight, washer, blower motor, like I went through. But then in my case, I had some really complicated CAN bus stuff I wanted to do. This took 20 minutes to figure out, 30 minutes to figure out. I'll tell you, it took me a lot longer to write the Arduino code that I had doing this before. And this is a lot more stable solution. So definitely pretty cool. I know they're going to launch it here soon. I understand there will be 16 and 24 channel versions, and it's supposed to be 1,150 pounds for the 24 channel and 830 pounds for the 16 channel, plus VAT, etc. I'm not going to do the math for dollars, as that can vary based on exchange. I think they may have some pre-order deals available, so if you're interested, I'd recommend hitting them up. But yeah, that's it for now. I'll do another video shortly with the car all dialed in and show what it looks like with live data logging, etc. as well. Thanks all. Have a good one.